Hey guys, sorry to cut out on you guys just at the last minute for this is going to be the end, so there's not much really left to cover. So this is just checking back on your answers again. So some interesting things that we should note here is when you had two objects like um, colliding, like when they're like if one's moving and it has like the same mass, um, usually when it's still, like when the other one is still, or if like the other one is kind of moving like slow and the other one's fast, okay? When they're the same mass, usually the items could either stop, change direction, or slow down. But notice when you have a really big object, a much bigger object, and the other one's like, I don't know, like let's say this is the big object here. Let me see. No. So yeah, here's a big object. I'll use my ring. Small object, no matter what, if this thing stayed still, okay, it would just kind of trail, or even if they both came at each other, this one would just kind of trail the big one, as you can kind of see, like on object A being really big, and this one, like this was the much bigger object in kilograms. It just slowed down and never changed direction. It never stopped or changed direction. So that's one big thing. But the big thing is, look, which one put more force on the other? Look, when you look at the effect on each of the objects, they always exerted the same force on each other. Isn't that weird? Even though you see the result, oh, sorry, kind of loud. Even though you see the result is a little bit different in the way, let's see, like some things change, like some things change direction, something stop, whatever the case is, the force that they put onto each other is always the same. Isn't that weird? Okay, that from all the examples, that's the big takeaway. So it's a bit of a trick question, what I originally asked you. Check out the video below. Which ball exerts a bigger force? Even though it looks like maybe, I don't know, this one seemed to put more force on that guy. The truth is, check this out, put the same amount of force on each other. It didn't matter. So that was kind of the trick. The force here and here exerted on each other. It's supposed to be shown like if this thing actually put on a bigger force on this guy, then you would have seen a much bigger red arrow. But they're the same arrow size because it's the same force. Okay, so that's kind of the answer. Um, you can kind of see that. Let's see the force on the white golf ball, which was not moving at all before the collision. It actually pushed. Let's see. It actually pushed forward or left, I guess. Um, and the force on the rubber ball pushed backward. Uh, or to the right. Okay, I think that's just actually a little bit more confusing. So just know that the force was about the same exerted on each other. So that's all you really need to know. Okay. All right. So we're still building our case for like we're still learning about forces. We're learning about collisions and forces. Doesn't matter what the collisions are between the two objects. It's the same force all the time. That's really useful to know. What else did we go over? Space pod size. We play with space pod sizes. Let's see. Sorry. Ooh. We talked about mass and weight, the difference between those two. Also, we found out that lighter objects too actually have a much more significant change in velocity. We're gonna like those aren't just random things. We're gonna take all those things into account when we're talking about the space pod and why it did not land on the space station. Okay, so we will continue this next week. Okay, so thank you guys so much for joining me. I know this is kind of weird, but hopefully it still was helpful and useful to you guys. Okay, especially on the homework, because I know the homework can be kind of confusing and you're going to miss out on all the little details when you're working alone. So hopefully I kind of helped there. Okay, guys, have a good day. Bye.